In this lecture, we will talk about examples for the graph of sine. We remember the graph of y equals sine x, which starts from origin. It goes to 1, when x equals pi over 2, and then it goes down to 0 when x equals pi, and then goes down continuously when x is 3 pi over 2, y is -1, and it goes back to 0 when x is 2 pi. And basically from 0 to 2 pi, it completes one period. Okay? And here are the actual 5 values for different x and different y. Again, if you don't remember, you always have your the calculator here, and here you have a cosine. You want to clear that and see how does sine x looks like. So you may graph it. Okay, so you see sine starts from what? From origin. Cosine starts from 0, 1. Okay, sine starts from origin. Yeah, that's different. Alright, now with those things in our mind, you know how we are going to draw the graph y equals 2/3 sine x. The only difference is what? Between those two is that there is a coefficient 2/3 in front of it. How does 2/3 play right here in this function? You know, x can still be 5 different values. 1, 2, 3, 4, 5. It can be more, no problem. You can put more here, but you know, here for the simplification, I only choose 5 different values. When x are those 5 different values, you have sine x. Of course, then sine x will choose 0, 1, 0, -1, 0. Okay? But, you know, 2/3 is in front of sine x. For each value you got here for sine x, you need to times 2/3. 0 times 2/3 is 0. So the graph still starts from 0, 0. But the highest point is changed. You know, when x equals pi over 2, you plug in right here or here, you still get 1, but 1 needs 2 times 2/3. So the highest point, rather than 1, it shrinks down to 2 over 3, or 2/3. And when x is pi, you have a sine x is 0, and 0 times 2/3, you still have a 0. Okay? So the x-intercepts are the same, 0 pi, 2 pi. The period is not changed, but the highest point or the lowest point will be different. You see, when sine x is -1, -1 times 2/3 is -2/3. So it was lower, -1, you see, lower, but -1 times 2/3 is -2/3. So is not that low as -1, it goes a little bit higher. Okay, so basically the range is changed from negative to 3/2 to positive 3/2. You see, it's actually right here, and previously was, this band was wider than this band. Okay, so basically the amplitude 2/3 is smaller than here. What? Here was 1. If you don't write, here is 1. Okay? So that's the first example we want to do. The second example is right here. Again, we based on what? We based on the graph y equals sine x. So we still want to use this graph. Okay. All right. Now you see down here, we may input 5 different values there. Previously was these 5 different values. Now again we can choose that because the period is not changed. The only difference between those two is here was 1 in front of sin x, here is -2. For -2, how does the -2 play right here? It's basically that for each value sin x, it needs to times -2. That's how it goes. Okay, so x equals 0 to 2 pi. We still get sin x, which have those 5 different values, 0, 1, 0, -1, 0. But for each sin x, we need to times -2. So 0 times -2 is 0. 1 times -2 is -1. So previously was 1. Now 1 here, you times -2, it goes down. It flipped from here to here, and it stretches. Okay, it was 1 there. Now it goes to -2. Okay, and again 1x equals pi. X equals pi, and then you have sin x is 0, and then -2 times 0 is still 0. Okay, so down here this point intercept is not changed, but 1x equals 3 pi over 2, you have a -1, the same. I want to emphasize is that those two rows are the same with the above. The only thing different is -1 here times -2, you get +2. Okay, it was right down here, -1. Now you times -2, it goes up right down here, and it stretches from 1 to 2. Okay, so basically this -2 tells us that flip the picture and the 2 stretches up more. Okay, yeah, so this is the picture. All right. Now, the second example is the one I shaded here. Is the one right here. All right. So let's draw the graph of y equals 5/2 times sin 1/2 x. And then, the first thing we want to be clear is that the period is changed. Because of what? Because of these 2 1/2. Because this 1/2. Again, you always use the coefficient as a denominator. Numerator is always 2 pi. Okay? So 2 pi divided by 1/2. 1/2 is 0.5, and 2 divided by 0.5 is 4 pi. Okay? So we know rather than the period was 2 pi, now the period was 4 pi. Previously, you do is that you can see from 0 to 2 pi, it completes either here or here, it completes one period. Because here the coefficient of x is 1. But here, the coefficient is less than 1. The period actually gets bigger. Okay, 4 pi. So from 0 to 2 pi, this one cannot complete one period. Okay, it's longer. It's basically the following pictures. Let's see. Let me do it that I want to use this one. And then I put it right here on the good screen. Yeah, this will include all the things. Do is I want to shade some things right now here. Okay. All right. So basically, we want again to use y equals sine x and to sketch this y equals 5/2 times sine 1/2 x. Now we have explained the period is 4 pi, and then y, the period is 4 pi. Look, when x is between 0 and 4 pi, the middle point is 2 pi, because 4 pi divided by 2 is 2 pi. And the middle point between 0 and 2 pi is pi. Okay, because 2 pi divided by 2 is pi. And the middle point between 2 pi and 4 pi is 3 pi. It's because you add 2 pi and 4 pi together is 6 pi, divided by 2, that's 3 pi. So you do is x is from 0 to 4 pi, that's one period. Okay? And then once you put each values into here, x equals 0 pi, 2 pi, 3 pi, 4 pi here, it has to multiply it by 1/2. That's why you need 1/2 in front of x, because it's 1/2 x. Okay? And then 1/2 x, when x is 0, 1/2 times 0 is 0. And then 1/2 times pi is pi/2. 1/2 times 2 pi is pi. And 1/2 times 3 pi is 3 pi/2. 1/2 times 4 pi is 2 pi. Okay? So you basically have a 0 pi/2 pi, 3 pi/2, and 2 pi. And that's the same value with the one right here. So if x has those 5 different values, then y will have the same exact values. So that's why you see down here, I want to emphasize is that those two rows are the same. Okay? Now, we have a sine 1/2 x, and 5/2 needs to multiply every value right here. Okay? Again, 0 times 5/2 is 0, but 1 times 5/2 is 5/2. Okay? So instead of 1, now is 5/2 here. So this 5/2 is bigger than 1. It basically from here stretches up to 5/2. And then when sine 1/2 x is 0 times 5/2, and you have a 0. And when sine 1/2 x is -1, you then have times 5/2, which is -5/2. So it's basically right here. Okay? And then when sine 1/2 x is 0, you have to multiply it by 5/2, because again 5/2 is in front of it. And you know that 0 times 5/2 is 0. -1 times 5/2, it was here. Okay? So you see down here, 0, 0 is the one right here. Alright? And then what? And then here I should write, rather than 3 pi, I should write pi here. When x is pi, then you have 5/2. X is pi, and then you will have y is 5/2. Okay? And then when x is 2 pi, you then have what? You then have y is 0. When x is 3 pi right here, and then you then have y is -5/2. And when x is 4 pi, you have a y is 0. So this picture looks, bigger. It's because the period is bigger. Okay? Yeah, it is bigger. Here was 0 to 2 pi, here was 0 to 4 pi. Okay, so this one makes period bigger when this coefficient is less than 1, and 5 over 2 stretches the picture. Okay, so that will be the graph of this one. All right, please review this lecture. I'll see you next time.